Welcome to lesson 5. This is actually going to be split into 2 parts, even though it's all together. So this first video is just going to be over the first couple examples, which is not using technology yet, and then the last couple examples will be on a different video showing that. Okay, so today we're going to be talking about how do we take a look at a line of best fit and determine, is it actually accurate? Okay. So the first way that we do that is by looking at the residuals. Okay, so a residual is the difference of the y value of a data point and the corresponding y value found on the line of fit. Okay, a residual could be positive, negative, or 0. Okay, so the scatter plot of the residual shows how well a model fits a data set. If the model is a good fit, then the absolute values of the residuals are relatively small, and the residual points will be more or less evenly dispersed about the horizontal axis. Okay, if the model is not a good fit, then the residual points will form some type of pattern that suggests the data is not linear. Okay, the easiest pattern that we typically see is some sort of U shape, either that way or this way. Okay, so that's what we're looking for. Wildly scattered residual points suggest that the data might have no correlation. Okay, so what we're going to do then is take a look at this first one, and we'll kind of go through this slowly. Okay, so there's 2 things that we're looking for. Okay, the first is, let me go back to the definition real quick. So the 2 things that we're looking for is that the absolute values of the residuals are relatively small, okay, and that the residual points will be more or less evenly dispersed about the horizontal axis. Okay, so we're gonna look at our residuals, look at them first, analyze them, and then we're also going to look at the graph that the residuals end up making. Okay, so here, if we take a look here, it says in example 3 in section 4.4, the equation y equals 10x plus 6 models the data from the table shown. Okay, and we want to find out, is this model a good fit? Okay, now this was not the exact line of best fit that we ended up getting, but it is the one that the book calculated. So we're going to go with it either way, because like I said, we can have a little bit of differences between lines of best fit, especially when we're doing them by hand. Okay, so if we take a look here, this first table is all of our data points that we had before, and here they are just listed again. Okay, so what we're going to do is we're going to list out what the y value should be based upon this equation, this model. So what does that mean? We're going to plug in the x value that they gave us, 0, 1, 2, 3, 4, 5, 6, 7, 8, okay, and then solve for y. Okay, so if I plug 0 in for the 10x, that gets me 0 plus 6, which is 6. Okay, and then if I plug in 1, I should get 1 times 10, which is 10, plus 6 is 16. Okay, so what we should notice here is that the y value from the model is just going to increase by 10 each time. So this should be 26, this should be 36, this should be 46. Oh man, I didn't realize how blurry this picture was until just now. Okay, but you get the point here. Okay, so this should be 66, 76, and 86. Okay, so then how we calculate the residual is we take the y value from the model, okay, we take the original y value and subtract what it should be from the from the model. Whoa, that was really poorly explained. We're going to take the y value column and subtract it from the one that we just did. So to start with, we get 9 minus 6, which is 3. Okay, 21 minus 16, which is 5. Okay, I'm going to stop writing out all the subtraction. 26 minus 26 is 0. 33 minus 36 is negative 3. 43 minus 46 is negative 3. 53 minus 56 is negative 3. 71 minus 66 is positive 5. 76 minus 76 is 0. And 89, oh, I wrote that wrong. It should be 86. 89 minus 86 is 3. Okay, so if we take a look, I'm going to erase these real quick so it's not so choppy here for these first 2 columns. Okay, so if we take a look at our residuals, remember the first thing that we're looking for is if we were to find out the absolute value of all these things. So in theory, get rid of your negatives for a second. Are these numbers relatively small? And the answer to that is yes. Okay, so that's the first thing that we're checking for. Now the second thing that we're going to do is we're going to go ahead and graph each of these points real quick, and we're going to take a look at the pattern that is shown on the graph. Now, we're going to use these as our x values and the residuals as our y, because that's what we're really looking for, is we're comparing these y values. Okay, so the first one would be 0, 3, that's right here. The next one is 1, 5, which is right here. Okay, then we've got 2, 0, I'm sorry. And then we got 3, negative 3. Okay, and we got 4, negative 3, 5, negative 3. Okay, 6, 5. Okay, and 7, 0. Okay, and 8, 3. Oop, that's 2. Okay, now if you take a look at this, I think what you could say is that it looks like we're starting to kind of get a U form. Okay, just a little bit, but with that said, I'm not really sure that we're so certain there, okay, because we're really just trying to figure out how close are these to the horizontal axis, okay, and so far this is looking okay. This is looking okay. So I would say with the with the information that we're given right now. Now, if we did some more points, we might have a different idea right now. Like if we all of a sudden saw this way skyrocket, okay, we might have a different thought, okay. But from what we can see right now, I would say this model is a good fit because first of all, the absolute values were relatively small, okay, and the points are more or less evenly dispersed about the x-axis. Okay, so for now we're going to say yes on this. Now this is probably a hesitant yes, not going to lie. So it's more like this, yes. Okay, for me. Now the textbook is very certain about this, that this is a very good fit. But like I said, typically I'm a little skeptical, especially when coming to a conclusion about this. Okay, I'm not really certain that we have enough data. Okay, and if I were you know, I would feel more comfortable if there was a point in there. You know what I mean? That way it doesn't fully look like a U-shape parabola going on. Okay, but for now we're going to say yes. And the next one, it's going to be a little bit more noticeable for us. Okay, so if we go ahead and take a look at the next example, we're doing the exact same type of thing. Okay, we're just trying to figure out is this going to be a good fit? Okay, now, okay. Here we go. It says the table shows the ages X and salaries in Y in thousands of dollars. Okay, of 8 employees at a company. The equation Y equals 0.2X plus 38 models the data. Is the model a good fit? Okay, so I've got my calculator ready to go here because I've got some decimals going on. So we just got to make sure that we're ready for that. So once again, we've got the table here to the left with all the points, with the ages and the salaries, and then we've also got it rewritten there again on the right table. So we're going to go ahead and start by calculating all those Y values. Okay, so it looks like I got to take 0.2 times my X value and then add 38 to it. So if I take a look at the first one, that's 35 times 0.2 equals 7 plus 38 equals 45. Okay, so 45 is the first number here. Okay, 37 times 0.2 plus 38 is 45.4. Okay, so oh, and hey, look, real quick, this one we're not going to be able to use our pattern necessarily because our X values aren't increasing by the same amount. Okay, so we're going to have to calculate each of these ones. Okay, times 0.2 equals that plus 38. Okay, I get 46.2. Okay, then 43 times 0.2 equals that plus 38. 46.6. Okay, 45 times 0.2 equals that plus 38 equals 47. Okay, 47 times 0.2 equals that plus 38 equals 47.4. 53 times 0.2 equals that plus 38 equals 48.6. 55 times. Okay, plus 38. All right, my last number is 49. Okay, now reminder, when we go to calculate the residuals, we're going to take the Y value that we're given and subtract the Y value from the model. Okay, so this first one we're going to get negative 3. The next one we're going to get negative 1.4. The next one we get 0.8. The next one we should get 3.8, oh, 3.4, I'm sorry. I can't find the eraser button. 3.4, ooh, let's actually write that in line. 3.4. Then we should get 5. Then we should get 3.6. Okay, then we should get 0.4. Then we should get 4. Okay. Negative, I'm so sorry, negative 4. All right, so all we do again there is we just subtract, okay? And we're going to take a look at what this looks like on our graph, okay? Now, this is going to be a little harder to graph here, okay? So I'm going to go by tens across this graph because the highest we need to go is in the 50s because I don't think I can count by 5, 7, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Ooh. I can count by 5s. Okay, so I'm going to go by 5s across my x-axis. I'm going to write that over here so you know that. Okay, and we're going to go by 1s on the residual. Okay, on the y. Okay, so remember we're using the old x values that were given, so we're using those, and we're using our residuals now as our y. Okay, so 35, 5, 10, 15, 20, 25, 30, 35. We're going negative 3. 1, 2, 3. Okay, we're going 30. Actually, hang on. No, this will work. Okay, 37, 5, 6, 7, and we're going to negative 1.4. 1.4, so it's roughly there. Okay, the next one is 41. 41, and we're going 0.8. So we're going positive. So we're right about there. Okay, then we're going 43, which is going to be on the other side of this box, and we're going 3.4. Whoa, 1, 2, 3.4 is going to be roughly right in there. All right, what next? 47 and 5. So this should be 45, 46, 47, and up 5. 1, 2, 3, 4, 5. Okay, now we're going 47. Sorry, 45. Oh, hang on. I jumped ahead. I said 47.5. It should be 45.5. I was looking at the wrong coordinate. I'm so sorry. All right, so 47 should be with 3.6. So 45. Hang on. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Hang on. Obviously, I can't count. So we're going to start over. That's my bad. Okay. I'd like to count by 5s, but we're going to have a break in the graph is I think what we're going to need here. So this is, we're going to kind of go by the fly here, guys. Apologize. So we're going to have a break in the graph, okay, and we're going to call this 10, 15, start at 30, 5, 40, 45, 50, 55, 60, 65. Okay, so this would be 65. 35, 40, 45, 50, 55, 60, 65. All right, now, time out. We'll start over. So sorry. All right, 35, negative 3, which would be right here. All right, now we're going 37. So 35, 36, 37, and we're going to negative 1.4. So we're going right there. 41, 0.8, right there. Oh, higher than that. Right there. 43, 3.4. 1, 2, 3.4. All right. 45, which would be here. 5, 1, 2, 3, 4, 5. Okay. What next? 47, 3.6. 47, 3.6. 1, 2, 3.6. All right. So that was 47. So now we're at 53. So 50, 51, 52, 53. 0.4. So we're right in there again. And 55, negative 4. 1, 2, 3, 4. All right. So now, hey, if we take a look at this, this is quite interesting. Okay. To me now on this one, this is very clearly an up-down curve. Okay. Which if we see that, which hey, actually, let's go back for a second. We're really remember what we're looking for is we're looking to see if our residuals, if we find the absolute value of them, if they're relatively small. And in this case, I would say, yes, they still are relatively small. Okay, but if we go ahead and take a look at the pattern that our residuals show, we end up with a nonlinear. So on this one, is the model a good fit? We would say no. Okay, and like I said, that would be because of the U-shaped pattern that the graph of residuals makes, which suggests that the data is not linear. Okay, all right, and that's the first part of this.